Students, welcome back once again to my channel. So today we are discussing one more topic, one more chapter. This is chapter number 12, and the topic is data communication and computer networking. This will have two videos because the length of the videos are more, so I have made it into two parts. At the end of the video, you will every time, as usual, in other topics and other videos, we'll discuss some important MCQs also, which are important for your exam. So welcome to Exam Success Series, Lateral Entry Masterclass for diploma students who wants to join the degree. All right. So today's topic, data communication and computer networking. So what is data communication, computer networking? As you can see, the data communication is the exchange of data, right? It's a data which can be exchanged between two devices via transmission medium. The transmission medium can be different, okay? But the exchange of data is nothing but we call it as a data communication. And networking, what is networking? The computers or the devices which are interconnected to each other, which can talk or send data to each other or receive data to each other. That is nothing but we call it as a networking. So these two figures will give you a little idea about data's transmission and networking. All right. So what are the components of data communications? Because data has to be sent, the data has to be sent somewhere and it has to be received. So communication, we call it as a communication. It's the fundamental characteristics of this is you have to deliver it, you have to send it. Data must reach correct destination. That is, we call it as delivery. Accuracy, data must be delivered accurately. That means the whole data should reach accurately. The third is timeline. That is, data must deliver in timely manner. That is, on the given correct or a predicted time, it has to go there. All right. The fourth point is jitter. Variation in packet arrival time. Jitter is nothing but variation. There will be a little lag of variation. That is, we call it as a jitter. So here, 5 basic components of your communication, that is, we have to study about that is, first is what we are sending. As you can see on the picture over here, data communication, there is a message. Okay. So first comes the message, then the protocol, the sender, and the receiver. These are the 5 basic components. So first is message, that is information to be communicated. Second is sender, that is a device that sends messages, right? Third is receiver, device that receives messages. Fourth is medium, physical path or transmission. The medium can be different. Okay. Fifth is protocol, set of rules. What is protocol? Set of rules already decided. That we call it as a protocol. Set of rule governing communication. All right. So these points you have to remember because we are discussing only point wise. We are not going into chapters. Now, next is data flow modes. What are the data flow modes? Suppose you want to send the data. What are the different type of modes you have? So one is, we call it as simplex. That is one-way communication. Example is keyboard, your computer keyboard to monitor. That means one-way communication. Radio broadcast, you can only listen. Okay. So direction is only one side. So as you can see, one-way communication. Half duplex. Second is half duplex, two-way, but on one at a time. That is two-way communication is there, but you cannot do it simultaneously. One has to stop and other has to go. But the communication will be both the side. Okay. Examples are walkie-talkies, direction both. That is one direction at a time. At a time. This particular word you have to keep in mind. One direction at a time. Then the third one is full duplex. That is, all the communication mediums nowadays, what we use are mostly full duplex. That is your telephone, mobile phones. So two-way simultaneous communication at a time. Both channels will be going together. It will be going and the other channel will be working together. That is, direction is both direction simultaneously. That is the mean. So data flow modes are simplex, half duplex, and full duplex. Okay. Now we'll talk a little bit about the networking types. So types and range examples. So there is a network called PAN, local area network, PAN, personal space we call it as, and examples are Bluetooth devices, LAN. The next one is LAN, building campus. That means little area is little bigger than the first one. That is the PAN one. Building campus. Office network, it is used. The examples are office network. The third is MAN, that is MAN, metropolitan area network. LAN is personal area network. So MAN is metropolitan area network. You can see here in this, I have given it here also. So MAN city they have used. That is, the coverage is more than the building and the campus. And the cable TV network is the good and best example for that. Okay. Then comes the fourth one, sorry, the WAN, the country and the continent, more bigger than the city. That is wide area network. Your example is internet. It comes from a longer distance and covers a long area. So these are the things that is network type, we call it as. Okay. Then we will study about network topologies, the important topologies. You have to understand this is a very important subject. Definitely you will get some question related when you are going on this particular topic. Okay, so first network is mesh network. That is every device connected to every other device. That is interconnection, or all are interconnected together. Right? Advantage, robust and private. Private, it will be very robust. Means suppose one fails, so it's not like that the others will not get it. So this is a robust, we call it, and private. So disadvantages, cabling. Why? Because the wiring from one computer to all the other computers or systems will be a little difficult or expensive. The second one is star, right? That is star topology, we call it as you can see here, the star topology, this in the figure. Center hub with all nodes connected. Center hub, there is a center hub. This dot you can see here, that is a center hub, and all nodes are nodes connected right together. Advantage, easy installation, manageable. Disadvantages are hub failure. If suppose hub fails, all the network is down. Okay, that is because you should know the advantages and disadvantages both. The third one is bus topology. Okay, single cable backbone. That is a main cable is there. From main cable, the distribution is taken. That is from main cable, the connection, that is called as bus topology. Single cable backbone is there. Advantages, economical, naturally the number of because the main cable is there. Disadvantage, limited length, fault detection, difficult, right? It's sometimes the fault will be, it's very difficult to, whether it is in the main line or whether it is the subline. So that is bus topology. The next is ring topology. Ring topology is nothing but an interconnection, as we call it in series, no? In electronics and electrical, it is connected in series. So likewise, it is connected in ring topology. Circular path. Exactly, the word is circular. What is the advantage? Equal access. Disadvantage, one node failure breaks network. That is the biggest step. Like one wire goes, all the system after that will be closed down. So these are the topologies what you have to understand. That is mesh, star, bus, and ring. Okay. Now, when we are starting, we should also, this is very important part, that is we should study about the network model, that is OSI and TCP IP module. So network modules, that is OSI reference module and TCP/IP protocol suite different benefits of layering, right? As what is layering? First you have to understand. So divide complex tasks into manageable layers. Modularity for easier updates, standardization of interface, interoperability between vendors, simplified troubleshooting. Right. So when we study about network models, so we should also understand, as you can see on the right hand side, a figure has been given. So there are different layer for that. So starting with first, that is bottom side, first is physical layer, right? Physical layer. Second is data link layer. That is physical layer is used by hub, repeaters, and cables. Okay, this is the physical layer. Data link. Second is data link layer that is used by switches and bridges. Third is network layer. Okay, that is used by routers. So these points you have to understand where it is used. Okay, layers. Fourth is transport layer, that is protocol TCP and UDP. Fifth is session layer. Sixth is presentation layer, that is ASIC2 to EBCDIC conversion, that is for conversion, JPEG, MPEG conversion, video and audio conversions, that is presentation layer. And seventh, finally, application layer protocol, where you use it, HTTP, FTP, SMTP, DNS, Telnet. These are the application layer. Okay. Okay. So these points, what I've given you, you have to keep it in mind. Now, TCP IP protocol suites. What is these actually? So these are TCP IP. There are 4 layers. What are those layers? First is network access layer. Second is internet layer. Third is transport layer. Fourth is application layer. Okay. Then OSI and TCP IP comparison. If you want to compare it, so the aspect OSI and TCP IP, the layer wise, when you compare it, OSI will have 7 layers, whereas TCP will have 4 layers. That we have seen in previous slide and this slide. What is the development? That OSI has theoretical and this is practical. TCP IP is practical. Approach, that is bottom up, this is top down. From bottom you have to count, from other way it is top down. Protocol dependency, protocol independent, and TCP IP model, protocol specific. User reference model, that is OSI model, and TCP IP, it is implemented model. So these are the points that you have to remember. When should we should also study about bandwidth and data rate when we talk about data and this thing at that time. This is also very important point you should understand. So bandwidth, what is bandwidth? The range of frequencies a channel can carry, that is in hertz or kilohertz or megahertz. That is, we call it as a bandwidth. What is data rate? Number of bit per second. That is, we call it as a BPS, number of bit per second. Now, what is the relation? Higher frequency bandwidth, higher potential data rate. Please remember this point. Higher bandwidth is equal to higher potential data rate, limited by channel capacity. Okay. Now, the next point is Nyquist theorem, we call it as, that is for noise cancellation. Okay. So you should understand this because probably you may get some this thing on Nyquist theorem also. That is some sums also you can probably expect. So maximum data rate is equal to 2 multiplied by bandwidth into log square under bracket L, where L number of signal level. Okay, so this part you have to understand, that is called as Nyquist theorem, right? The theorem part is what you have to understand. The next will also come one more formula, that is, we call it a Shannon capacity formula for noise. This is also for noise cancellation or noise related. C is equal to B into log 2, that is 1 plus SNR, where C is channel capacity, BPS, that is counted in BPS, that is bit per seconds, and B is equal to bandwidth, that is in hertz. We have SNR, signal to noise ratio, SNR in dB, that's a decibel, SNR dB is equal to 10 multiplied by log 10 SNR under brackets. So these points which I have given you, it is very important and you should remember this. Transmission degradation of signal quality. This is also very important point. That's why I have added this also. So which is called as, one is called as attenuation, second is distortion, third is noise. It looks similar actually, but what's the difference? So here attenuation, loss of signal strength with the distance compensated with amplifier repeaters measured in decibels. Okay, dB we call it as. And distribution is different frequency travel at a different speed affects composites signal. Naturally, it will affect the composite signal. These are the points which I have written or I have taken out for you people because it is important. So noise, unwanted signal interfering with transmission types. Okay, thermal, induced, crosstalk, impulse. These are the noises we call it as. Now, decibel dB calculation. This is also very important. The purpose is measure relative signal strength. Formula is dB is equal to 10 multiplied by log power 2 by power 1. I have given you the ratio, the different ratios in this example. So you can go through this also. That is, we call it a decibel calculation. All right. So we'll come to the final part of this. That is, we will study about the MCQs. That is few questions and we're given the answer. What are the 5 basic components of data communication? The correct answer is sender, receiver, medium, protocol, message. Okay, out of this 4. Second question is, which data flow mode allows communication in both direction? That is full duplex. Question number 3, the fundamental characteristic of data communication includes all except what? So the except what is the correct answer for it? D, that is encryption data must be securely encoded. Please understand the question, then you can answer it properly. The question number 4 is, which network type typically covers a city and is exemplified by cable TV network? That is a MAN, metropolitan area network. So cable TVs, where the companies send signal to a long distance, that correction. That's why it is called as MAN, metropolitan area network. 5th one is, in which network topology does the failure of a central device bring down the entire network? Star topology, which as we have discussed before. Question number 6, how many layers does the OSI reference model have? It has 7 layers. That also we have seen. Okay, right. So now these are the 7 network layer. Which layer of OSI model is responsible for routing and user device like routers? Network layer. Which protocol, that is question number 8, which protocol operate at the transfer layer of the OSI model? TCP and UDP is the protocol, okay, operate at the transport level model. According to the next question and the final question, 9th is, according to the OSI versus TCP IP comparison table, which statement is true, right? please go through the fourth statement. The OSI is protocol independent. TCP/IP is a protocol specific. This statement is correct. Okay. So these are the questions. I hope you liked it. This was our first part. I will come with another video, final video. That is the second part of the same topic. We'll discuss more questions and more topics in that. Thanks for watching. Share with your friends. Any comments, please do write to me. I will certainly try to answer it. Thanks for watching.